moving from a sedentary to a physically active societal way of life. This is Up on Our Feet.
Welcome to Up on Our Feet. Over the past 30 to 40 years, research in neuroscience has conclusively shown how physical activity positively impacts cognition, how our brains work. We've learned that the brain is not just a thinking organ, it's also a movement organ. And this relationship is symbiotic. It goes both ways, that the brain affects physical movement and this movement affects the brain. More recently, studies are showing the same thing with music, that it too has a positive effect on the brain and how it works. And most recently, we're learning that physical activity and music together can have a positive effect on the brain that is more pronounced than either activity by itself. There's a synergistic effect that takes place where the sum of these two activities on the brain is greater than either one by itself. And here to discuss all of this is Dr. Psyche Loui, Professor of Creativity and Creative Practice in the Department of Music at Northeastern University's College of Arts, Media, and Design. Professor Loui is the director of the university's Mind Lab. This is an acronym for Music, Imaging, and Neural Dynamics. Professor Loui is also a member of the American Sports Institute's International Board of Advisors. Professor Loui, it's nice to have you with us.
Thank you for having me.
Sure. Okay. We know how long research has been around regarding the effect of physical activity on the brain. What about for music? How long has the research on the effect of music on the brain been around?
Well, if you think about the effect of music on psychological processes that are maybe enabled or coupled with brain activity, like music and emotion, that's been around since the ancient Greeks, right? In some ways, Pythagoras, right, the ancient Greek mathematician and philosopher, had noted that if you look at physical vibrations of, let's say, a string, if you have two strings that are vibrating together in integer ratios of frequency, those sounds sound good together, right? In fact, the word symphony comes from the idea of sympathetic vibrations, or mathematically related sounds that are sounding together, and then the idea of consonance emerges from that, right? And then the idea of harmony, the idea that sounds that are related in integer ratios sound good, and that's kind of the basis for musical structures and musical systems around many parts of the world. And so I think in some ways it dates back to Pythagorean times, but really the modern neuroscience of music really, I'd say, started in the last few decades, right? And so some of that was intertwined with music psychology, the idea that music, certain expectations in music change emotions. And then there's, of course, the famous idea of Mozart effect, where there was the finding that if you're listening to music by Mozart, then that influenced your IQ or executive function scores by a few points, and that turned out to be pretty much debunked by now. And that was in the 90s, and so I think that was a major advance in how people were thinking about the effects of music on cognitive and brain health. But today we're using much more, hopefully much more sophisticated methods to look at not just behavioral output, but also brain mechanisms that underlie the cognitive and scholastic or academic performance.
Okay, then what does the research show? Just how does music impact our brain?
Well, there are many things that are still being found out and still being studied, but we know that children who have musical training and who undergo musical training tend to do better in academic tests and scholarly tests, and also in neuropsychological testing. And so we've done a little bit of work on that, but there's there are many more groups around the country and around the world that are finding this out. We also know that there are major pathways in the brain, especially my lab has looked at white matter pathways, such as the arcuate fasciculus, which is a major pathway that's important for language. And that pathway is strengthened by musical training. And there are some studies that we've done that are cross-sectional studies, just comparing, let's say, children with and without musical training, formal musical training, whereas and other labs have also done studies that are longitudinal, right? So tracing the development or change of that arcuate fasciculus before and after, let's say, a week of intense musical training. And so, so the arcuate fasciculus is one of, I would say, is a core pathway that's involved in how music engages the brain. And so, yeah, there are many more things I can say. We can talk about music and its effects on emotions. We can talk about music and its effect on language functions, but those are the major categories, I'd say.
Okay, so question. I assume this is more along the lines for people, and you were talking about kids playing musical instruments. Does listening to music have the same kind of effect on the brain as playing an instrument? Is there a difference? Does listening to music impact the brain at all?
Listening to music definitely impacts the brain. It impacts multiple areas of the brain. And this is true of many different points in the lifespan, and that's been very clearly shown. In fact, there's the Global Council for Brain Health, for Cognitive and Brain Health, which is part of the AARP, has issued a set of guidelines on how music can be helpful for brain and cognitive health as we age. So that's one set of results. I mean, we know that music impacts many different areas of the brain, starting with, for example, the auditory system, right? So starting with the whole peripheral auditory, the auditory nerve and the cochlea, and all the way up to more central areas of the brain. So areas such as the medial prefrontal cortex, that's involved in reward processing. So when we're listening to music that we love, that we find pleasurable, that we find rewarding, that reward system, which works with the dopaminergic system of the brain, that is highly active and it's engaged and it's more functionally connected. So not only when we're listening to music, not only are the auditory systems active, not only are the reward systems active, but these two systems are talking to each other or more connected to each other.
Okay, so there are just a whole host of issues going on in the brain and areas of the brain regarding music, both playing and listening to it. It's quite extensive, right?
Absolutely, yeah.
Okay, so question then, and I don't even know if you have an answer for this or if there's any research on this, but why does music have such a positive effect on our brain? Is there a reason or purpose behind this? Are we genetically programmed to be musical?
That's a great question. And I think we're just starting to find out the answers, right? So first of all, why? The question of why can be answered by so many levels, right? So there are some groups like in Vanderbilt University Medical Center are starting to look at genetic correlates of musicality, right? So are people who are good at music, let's say good at rhythmically clapping in time to a beat, do they have certain genetic profiles that people who don't clap to a beat don't have, right? So that's one set of ways to answer the question. Another set is really just trying to disentangle why music has a positive effect from the brain on the brain from other confounding variables that might be also related to both musical training and brain gains or brain changes or cognitive changes. So, and I think with some randomized controlled trials that are starting to be done in this country and also in around the world, we're starting to look at whether music-based interventions, so singing, for example, or dancing, or just listening, or listening in groups, right? So how do those different components separately impact the brain in ways that cannot be predicted by just hanging out with other people, right? Or speech, right? So a lot of music we know has a lot of overlapping components with speech, right? Both involve listening to sounds, but speech has certain acoustic parameters that tends to be less than music. Music has more certain acoustic parameters that maybe are a little bit less part of speech. So I think those are the randomized controlled trials, and that really get at the why and the specific active ingredients that music-based interventions might be imparting upon brain and cognitive health.
Okay. All right, let's talk a little bit now about, as we mentioned in the introduction, about the combination of physical activity and music on the brain. And regarding the research on this combined effect of physical activity and music on the brain, what's going on here? Because, you know, I saw that one study that showed that together the two have this combined synergistic effect of having a greater influence on the brain than either one separately. What's this about?
So first of all, we should think of music, active music practicing, right? Not just listening, but actually performing and practicing music as a mild form of physical activity, right? So for example, I play violin. I mean, it takes focus, it takes executive function. It also takes physical activity and physical movement. So in that regard, when you're practicing a musical instrument, let's say half an hour a day, that can almost be added to physical activity. And so it's not so surprising that there's some additional effects, but some additive effects. But as you say, the synergistic effects maybe come from some additional benefits that music has, or maybe additional parameters that music introduces to what our brains are exposed to. For example, sounds and patterns of sounds, right? Music, in a way, is really about the structured patterning of intentions and predictions. So when you're listening to, let's say, what's your favorite band, or what are some of your favorite music to listen to?
Oh, you're asking me, right?
Yeah.
Oh gosh, Bob Dylan or.
Okay, yeah. So when you're listening to Bob Dylan, you have certain knowledge about how it's likely to unfold, right? And so is there a specific song, a Bob Dylan song that you enjoy the most?
Yeah. Like a Rolling Stone.
Right. Yeah. So like a rolling stone. So when he says like a rolling, you expect the stone, right? And if it ends up being, like a rolling moss, you was, well, that's not right. That's not how you expected it to go. Even though moss is technically a noun, and you would expect a noun there. So the linguistic, even though you don't say like a rolling moss, but the effects of that line, when and the expectations and the predictions that you're forming quite actively when you're listening to that music, it's synergistic in across the different components that music involves. So you think about maybe the guitars and the rhythm section and the words all kind of coming together in ways that engage and that guide your predictions in a way that is more than if each of those acoustic components were just unfolding by itself, right? So and it's this systematic interplay between predictions and reward, like the dopaminergic system that we talked about, that really motivates the brain to keep listening to more music and keep driving and using those predictions to drive the learning experience. And so not only then would you want to listen to more of the similar kinds of music, but you would actually maybe seek out new music that has that gives you the similar ability to predict and to test those predictions with sounds as they're coming in. So in that way, I think this auditory patterning or prediction and reward mapping is a really important addition to the things that we already talked about, which are language and the archaeophysiculus, and both of those together maybe make music a synergistic kind of activity compared to, or in addition to physical activity, on its effects on brain and cognitive health.
Okay, that's really interesting. All right, let's do something here. We a few moments ago we were talking about, are we genetically programmed for music? And we've just been talking about the combined effect, synergistic effect of physical activity and music on the brain. So again, regarding our genetic programming and in the context of this combined effect of physical activity and music on the brain, we mentioned earlier, we know that over millions of years of evolution, human beings have been genetically programmed to be physically active. And not only do our bodies respond positively to physical activity, but so do our brains. With the research that you and others have done, is there any evidence showing that over these same millions of years of evolution, in addition to physical activity, human beings have also been genetically programmed to be rhythmic? And if so, is this possibly something that makes music and its rhythms so compelling to our species? Do we have an inherent need or inclination to be rhythmic?
Yeah, that's a really great question. And I think that's a very active area of research. So I think partly the answer is likely yes, because rhythm is a guiding principle across many different musical structures around the world. And it's also a guiding principle for predictions, right? So when we're listening to, let's say, Bob Dylan, or, when a person in, let's say West Africa is listening to music in that culture, we're using rhythm to guide our predictions for when, not only what's going to happen, but when something is going to happen. And it's also a helpful way to reveal different cultural differences. So let's say West African music tends to unfold with certain different rhythmic patterns, often actually more complex rhythmic patterns than, let's say, Western classical music. And so because of that, I think rhythm serves as a really kind of low-hanging fruit almost for genetics researchers to find, to look for patterns of genes that might be predictive of this rhythmic ability. And there's a major paper that just got published, I think, in Nature Human Behavior this year. And so my colleague, Raina Gordon, would be the one who is the last author on that article. And what they did is they did find some patterns of genes that are predictive of individual differences in rhythmic ability. Yeah, so I think the answer is yes, but we're really just getting started.
So speculating here, I know we have our 24-hour circadian rhythm, right? Our waking patterns, our sleeping patterns, things like this. A developing fetus inside the womb has the mother's heartbeat and pulsating of the blood. The growing fetus has its rhythmic beat of its heart. Has there, with this innovative or the new research that's being done, has there been any talk or links between that kind of rhythmic way of being we have and the connection to rhythm in music? Is there anything like that?
Yeah, that's a great question. I'm really glad you bring that in, because if you think about rhythm, it's not just clapping, right? It's not just the clave patterns of different cultures, but also rhythm as a pattern over time, right? It unfolds at many different time scales, and so much like our rhythmic patterns within musical time structures, time sequences, we also have brain rhythms, right? So, for example, right, the brain is never completely still. It's really large networks of neurons and glia and neural populations that work together to make the different systems of neural activity work and to enable cognition. And so these different large-scale neural systems are working together in rhythmic concert, right? Essentially, you have certain groups of neurons that are firing at fast rates that are predictable, and then other groups of neurons that are firing in slower rates that are predictable. And so, for example, when I'm looking at, when I'm trying to do talking, have a conversation with you right now, and I'm doing effortful work, trying to read or write a paper, there are certain groups of neurons that are firing at fast rates. So let's say gamma rates, and those fast rates, let's say 40 hertz, 40 cycles per second, right? And then in contrast, when I'm spacing out, right, or if I'm mind wandering, or not paying attention, or even dreaming, right, then those kinds of brain patterns are much slower, ultra slow brain patterns that unfold over, let's say, tens of seconds. And so these different nested, like almost hierarchical structures of brain rhythms are together what's important for normal and healthy cognitive processes. And so we know that with aging, or even with healthy aging, we have some normal degradations or disruptions of these rhythms and these rhythmic coupling across different timescales. And then especially in folks with Alzheimer's disease, right, or Parkinson's disease and different neurodegenerative disorders, this normal rhythmic coupling is really disrupted, and that leads to disordered movement, that leads to disordered cognition, right, or working memory problems that you might be familiar with in a variety of neurodegenerative disorders. And so that's why, because music has these predictive qualities and musical rhythm tends to unfold in fairly well characterized ways, we think of music as a way to potentially offer new interventions for folks who might be at the early stages of these neurodegenerative diseases and disorders. So, for example, we're looking at folks with Alzheimer's disease and trying to see how, if you take the rhythm that's intrinsically part of the musical signals and then add to it maybe with lights, or maybe with different colors of flashing lights, or different rhythms of flashing lights, whether that might have an effect on the resultant rhythmic brain activity. And there's some evidence in a mouse model of Alzheimer's disease showing that could work, right? So in particular, these lights can be used as a restorative, rhythmic properties of lights can be used to restore the brain rhythms that are disrupted in the mouse model of Alzheimer's disease. And so what we're trying to do here is use music as a carrier, right, to bring something that's kind of disrupted in the Alzheimer's brain, and use music to kind of deliver that replacement of disordered brain rhythms.
Okay, that's
yeah.
really
So that's really in the pipeline right now, but I think it's a very exciting way to think about music, not just as a way to feel good and sound good, but as a way to help folks with neurodegenerative disease.
Okay, so talking about that, I'm thinking about, okay, how does this relate then to kids in school? And given, we were talking about earlier, the synergistic positive effect of physical activity and music on the brain, what do you think are the implications of this regarding education and how kids learn?
Yeah, there are many different implications. So, I think of music as not just one experience, but really a grab bag of different possible experiences, right? So there's listening, there's engaging, there's choosing your own playlist to listen to, and that's already kind of a more kind of, there's like already added agency to that experience. There's of course playing music, learning to play music, and then there's sitting still and actually practicing your musical instrument for an hour a day, right? And so for children who are early school age, right? Getting that kind of extensive practice where you're really trying to focus on something for an hour a day or half an hour a day, that in itself is hugely beneficial for executive function. And so I think it's because of that children with musical instrument experience are better at executive control tasks, and that's been shown in many different studies. So especially, all right, there's the finding of this finding is, I think, entangled with social emotional gains that children can have from musical training, right? So if you're better at, let's say, not shouting, or not overreacting with every small small event that doesn't go the way you plan, then maybe you might be better at interacting with other children in school, right? And then that leads to different social emotional gains, so I think that's the social emotional part is entangled, I think, with the executive control part, but both seem to be children with musical training, especially musical instrument training, seem to do better at both these. Mm-hmm. And there's a group in the Brain and Creativity Institute at University of Southern California who's really doing great work on this topic.
Okay. What about then this related to, the combination of physical activity and music regarding the kids in school related to academic performance? Is there any research on that?
Yeah, so I think some of that is by the same group, right? So extending the results from physical activity and from musical training on cognitive, neuro and cognitive measures towards academic achievement outcome scores. And so our colleague Chuck Hillman at Northeastern University, who's also on your advising board, right? So he's kind of a world expert at that. But so in our collaborations, we're also seeing that the combined effects of both physical activity and musical training seem to have synergistic effects on neurocognitive outcomes that also then translate to academic achievement scores. But I should say that it's not totally case closed yet, because while the physical activity part of that study is a randomized controlled trial with a waitlist control group, we haven't done exactly the same thing with musical training yet. So that part is just comparing children with musical training versus children with no particular musical training. But of course, they would probably have heard music just because they're in the world and there's music all around them in the world. And so we still need to do the real randomized control trial that systematically controls for just music lessons while offering a reasonable control group for whoever's not getting musical training.
Okay.
And I think there are some ethical issues associated with that, right? If you already know that musical training is something that the children would enjoy and is something that would help the children's brain and cognitive outcomes, then what exactly is a viable control, right? And I think that that's also why this collaboration with researchers who study physical activity and its effects on brain and cognitive health is a really helpful one, because maybe we can think about soccer, let's say, as a kind of physical activity, as opposed to violin or flute as like a musical activity, and then those are then somewhat well controlled or somewhat more comparable activities that children can engage in over a long term.
Yeah. Okay. This is all really, really fascinating. So in that context, what's ahead regarding future research on how music impacts our brain, especially when combined with physical activity? Where is all this going?
Yeah, I mean, I think the study that I essentially just described, that would be a really great next step, right? I mean, trying to get that project started would be great. And then also in the other end of the lifespan, right, looking at how music listening and maybe selecting one's own music to listen to, right? So the kind of the fine-grained details of how we create our own musical experiences in life, how those might be useful for cognitive and brain health, especially for those with neurodegenerative disease. Yeah, I think those are the two major kind of more applied research directions that I'd like to go in, and I think that will be of interest to folks across the field, but also some of the more pure research questions that you're alluding to, right? Like, why do we have music, right? So, I mean, I happen to think, and we've written a lot about this, that that music exists because humans are a social species, right? So because we have each other and we want to make music for each other, and so there's every culture in the world has music, and every culture in the world makes music for each other, right? And so I think of music and social bonding as very fundamentally linked. But that's quite a high level explanation for why we have music, right? So, and there's some more low level explanations that are more like, well, when we're functioning in society together, we predict each other's actions, for example, right? And so when you're nodding your head, I use that as a cue to say, oh, you must be understanding what I'm saying, right? Or when we're talking to each other, right, we kind of have this turn-taking effect where I talk and then I expect you to talk and then you expect me to talk, and so that kind of rhythm unfolds in a way that's maybe similar to how like a musical playing situation might also unfold. And so so there are many more questions about that relates to questions like creativity, right? Where does creativity come from, and why is it that when there's a band that's jamming together, right, there are some folks that can jam together and make a really creative sound, really exciting sound, and really captivating and engaging sound, and then there are other bands that when they play together, you're just like, oh, that didn't work well. Even if individual musicians are great players, they might not play together. So like, why do some bands click and others don't, right? So, and that's a kind of I think question that's more pure research question at this point, but it also, if we understand that, then can we use that to adapt towards music-based interventions that can be, let's say, helpful for maybe children with autism, right, or children or people with different, social abilities. So, yeah, so I think there are many levels of questions that can be asked. The sky's the limit, really. But at the heart of it, I think it's a set of more applied questions and also a set of more basic research questions.
Okay, very interesting. Final question. With all the studies you've done and all the papers you've authored and co-authored about the effects of music on the brain, including in combination with physical activity, in the big picture of things, what's the big message, the big takeaway, the major conclusion you've come to?
I would say that music engages multiple parts of the brain and multiple networks, and it's the systematic fulfillment and violations of expectations that engage the reward system that then makes music so rewarding and engaging to listen to. So I would say that's the kind of biggest high level answer that my research has provided for now. But there are many more things I can say. It's hard to summarize it in one sentence.
Okay, well, that one was pretty good. All right, Professor Psyche Loui of Northeastern University, thanks for being with us on Up on Our Feet.
Thank you for having me.